To start, we will talking about temperature inversion. Yeah.
Sir, if we say which height temperature decreases, question comes, then it is true or false?
It is true.
But when you go to troposphere to stratosphere, this trends like
that there are exceptions. That's what we are talking about, temperature inversion.
In general, if question
General, this decreases. The decreases. In general, when we talk about the decrease of temperature, it will be true that temperature decreases with increasing height. Right? There are exceptions for that, and that's what we talk about, temperature inversion.
How the amount of insulation on same lake will be seen. So there are various factors like clouds.
That will be the smaller factors. That will be the local factors which might be obviously affecting that. Overall, it will be same. Generally, when the clouds are formed like ocean surface, the cloud formation chances are more. In the continental areas, relatively dry. So that will be there as a factor. But when we talk about a statement, there will be a general statement which will be largely true. And there is always an exception of every general statement. Right? So what you are talking about is perfectly true. That is a general statement. For example, if in the preliminary examination is asked that there is always equal amount of insolation over all the places located on the same latitude, wrong statement. Always wrong statement. But there are that in general, all the places located on the same latitude will be having equal insolation, true statement. So whenever the abstract statement is there, in all likelihood that statement will be wrong. Right? So temperature inversion is basically exceptional situation in which the temperature increases with increasing height. Right? And normally what we have read, because of environmental lapse rate, the temperature decreases with increasing height. And this is an exceptional situation. That's what you call temperature inversion. Inversion means inverted, exactly opposite of the normal rule in the case of temperature. Right? So that's what we call temperature inversion. The best example of temperature inversion is in the mountain and valley region. For example, generally what will happen, the valley will be relatively less exposed to the sun's rays, right? And the mountainous top will be more exposed. So in the daytime, the temperature of the top of the mountain will be higher as compared to the valley. So here you have lower temperature, and when we move higher up, look at with the increasing height, the temperature decreases. Temperature increases. Similarly, just imagine the two air masses, one is cold and one is warm, is converging in a region. Right? So cold air mass being denser and heavier will occupy the ground and will displace the warm air to rise up higher up in the atmosphere. Now imagine in this region of convergence, the ground temperature will be lower and the higher up the temperature will be more. Right? So that is temperature inversion. Now, if you look at the temperature inversions, that was the simplest possible example we have talked about. If we look at the overall temperature inversion, that is temperature inversion within the troposphere, or that's called tropospheric inversion. Right? Then we have this called upper air inversion. Generally, largely temporary in nature. Largely temporary nature. They are not permanent. They are situational. Both temporal and spatial manner. temporary in both temporal, like with respect to time also they are temporary, with respect to space also they are temporary. For example, one space at a particular point of time might be experiencing temperature inversion, other may not be experiencing, right? So what we are basically concerned about is tropospheric inversion, which directly have its impact over the humans. The moment we are talking about upper air, they are generally permanent in nature. Generally permanent in nature. One is troposphere, stratosphere. Second layer of the atmosphere, right? In this layer, it is a general trend that the temperature increases with increasing height, right? So when we talk about stratosphere, the reason is the presence of ozone particles. In this particular layer, right? What does ozone do? It absorbs the ultraviolet rays. A particular type of insolation is absorbed in that region. Consequently, what happens that the temperature of that particular region is higher than the normal. That's why in general the temperature will increase with increasing height. Right? So that is, but if you look at the permanent nature stratosphere, then we have ionosphere also. In this layer also, the temperature increases with increasing height, basically because of the closeness with the sun and ionization of gases. That's why it is called ionosphere. Ionization of air particle takes place where that's why ionization, ions, I hope you understand, whenever there is exchange of electron and proton between the particles, that's what takes place and energy is released. That's why they have higher temperature. And when we go up, the temperature increases. But in the ionosphere, the temperature is not felt by humans basically because of rarity of the atmosphere. So the air temperature, since air is very rare in that area, so overall temperature might be more, but human may not be able to feel that high temperature because air is very less in amount.
We can say that the only due to the presence of ozone layer in stratosphere, the temperature increases.
No other fact. The only reason is that. Otherwise, Earth is the most important source for atmospheric energy. We have already talked about that. Right? Out of 65% energy what ultimately Earth atmosphere system receives, only 14% is received by insolation, and the rest of the 51% is supplied to the Earth by to the atmosphere by the Earth only. So Earth is a major source for atmospheric energy. Stratosphere? No, the troposphere largely have temporary inversion. The area will not be having permanency of inversion. The general rule in troposphere is that the temperature will decrease with increasing height. But in exceptional circumstances, sometimes in winter season, sometimes in desert area, maybe urban areas, will come to that. So that reason will be there. There will be a specific reason for that, because general rule is the height, with increasing height, temperature will decrease. So there will be exceptional circumstances, except in polar region. So there are several reasons, we'll talk about it right now. Right? First, now we have to understand what is temperature inversion is. The temperature increases with increasing height, right? That means if you pick up a particular layer of the atmosphere, that will reflect higher temperature than this, right? Now, atmospheric energy is fundamentally supplied by the Earth, especially when we are talking about troposphere. So, if in any circumstances or in any situation, when the radiation from the Earth is more than normal, then Earth will be cooling at a faster rate and atmosphere will be gaining energy at a faster rate. Can we understand? If the temperature gradient is steeper, yesterday we have talked about that. If the temperature gradient in any region is very steep, then what will happen? The rate of cooling on the surface will be more, and the rate of gaining atmosphere will be far more. For example, let's say suppose that the two bank accounts are connected with each other. Let's say Ambani is connected with mine, right? So Ambani always will have higher amount of money. So you can consider that as Earth's surface, because Earth's surface is receiving insolation that will be more in quantity always. So you can treat Ambani and Earth's surface. Now me as atmosphere, if Ambani is supplying to my account, so ultimately the supplier has to have more amount of this thing. So that is decreasing order. This is a normal situation. In what is the condition, possible condition, when I might be having more amount of money as compared to Ambani, looking at the fact that I am having the only source or the major source is Ambani. When the rate of flow of his account is far more and I am gaining all that. So after a point of time, there may be, though there is not such possibility, he is supplying money into my account. So after a point of time, my account might be showing maybe inflated this thing and his account might be having lesser. Similar fashion, whenever a situation is arising on the Earth's surface, when the rate of terrestrial radiation is far higher than normal, then the surface temperature of the Earth will be lower than the atmosphere above it. That will produce chances of temperature inversion at a particular point of time. Now, first thing you remember that when we talk about temperature inversion, it may not necessarily stay for 24 hours. It may be for the period of some middle of night, it may be early in the morning, right? So, either the rate of terrestrial radiation is high or the amount of terrestrial radiation is high. Hopefully, we can understand. So, fundamentally, temperature inversion will be associated with the rate or amount of terrestrial radiation. If the surface is losing at a much faster rate and atmosphere is gaining with the equal amount of rate, so after a point of time, the surface may show lower temperature as compared to the atmosphere above it. Now, that's what will we call temperature inversion. Clear? Hai? So, temperature inversion is directly associated with the extraordinary rate of terrestrial radiation or the amount of terrestrial radiation.
So in winter season, radiation will be also important in the night because in winter on the night radiation is long.
So the amount will be more. So the atmosphere will be gaining more. So when we compare winter and summer, the chances of temperature inversion is higher in winter than in summer. We are coming back. Now, just you can correlate with the concept. You will never forget. Now, when we are talking about the extraordinary rate of terrestrial radiation, that will be determined by temperature gradient of the area, vertical temperature gradient. Right? That will be determined by vertical temperature gradient. Now, when we talk about vertical temperature gradient, that ultimately will be determined by the temperature range. The area which is expected to have higher daily range of temperature will be expected to have producing or greater chance to produce temperature inversion. Can we correlate it?
Delhi and Mumbai.
In Delhi than in Mumbai. Yes, of course. The temperature range is expected to be higher in the interior of the continent. So obviously, when Earth is losing at a much faster rate, obviously then if the day temperature is very high, that means the evening rate of terrestrial radiation will be very high. So by the middle of night or maybe early in the morning, that this surface might have lost much greater amount of temperature, energy, and whenever it is losing, who is gaining? Atmosphere. So atmosphere might be showing higher temperature than the surface. Is that clear? Now, conditions favorable for temperature inversion. Conditions favorable for temperature inversion. What do you see? Again, range of temperature will be one condition. When the temperature range, especially when we are talking about temperature range, that is daily range of temperature, is higher, must be higher, right? Cloudy nights and clear nights, which one is expected to have higher chance of temperature inversion? Do we understand it also? The answer is true, clear nights. What will happen? In the cloudy nights, there will be counter radiation. So the energy will be sent back towards the earth. So earth's surface might not be losing its temperature or at the rate of desired level to produce temperature inversion. So obviously, clear sky or nights are more favorable for temperature inversion. Winter nights or summer nights? The season. Summer nights, then we look at here, right? That's again a confusion. Generally, when we look at temperature range or when we are talking about the steepness of temperature, why we are talking about temperature range? Because of temperature gradient. And what is that temperature gradient? Is the vertical temperature gradient. When we say temperature gradient, we are talking about the difference in the temperature of surface and the atmosphere above it. That's what we mean by vertical. So do you expect, now a question is that, do you expect that the temperature gradient will be different in winter and summer? Why?
Atmosphere will be cooler.
Why? Now, all of you know it. We have understood it. The only thing is that this is beyond the books, where it is not explicitly mentioned in the books or explicitly discussed. Now, temperature ranges, temperature gradient is the difference in the temperature of the surface and the atmosphere. Let's talk about summer season. You think by yourself, right? If the surface temperature, let's assume any place on the surface of the earth. Let's take Delhi, for example. So what is the temperature of Delhi in summer season? Roughly, by evening, 40. And what is the temperature at 1 kilometer above it by evening?
34.33.
Beautiful. The temperature of the upper layer of the atmosphere will be determined by the normal environmental lapse rate. So at 1 kilometer above the surface in the atmosphere, the temperature will be roughly around 6.5 degrees Celsius less than the surface. So what is the temperature gradient? 6.5 degrees Celsius. Let's assume during winter. What is the temperature of the surface on Delhi by evening? 20, 25, 20 around. Now 1 kilometer above it, 13.5, the temperature gradient by 6.5 degrees Celsius. So we don't have any specific reason to believe that the same region, same area would have different vertical temperature gradient. during summer and winter. Is that clear? So when we talk about seasonal aspect, seasonal variation in terms of its effect on temperature inversion, the ultimate determinant will be the duration. So longer winter nights, shorter days during winter season. So receipt is less, right? But loss duration, because of duration is much bigger, so loss from the surface will be far higher, and the atmospheric amount, the amount of energy the atmosphere is receiving will be equivalent to that loss, whatever it is done by the Earth's surface. So that's why longer, cooler winter nights are more favorable for the temperature inversion. Calm condition or windy condition, which one is more favorable? If the wind is blowing, calm condition is more favorable. Why?
Because if there is a windy situation, then heat will be transferred from one area to another.
Horizontal mixing will be there, and temperature inversion is all about vertical. So that's why calm condition rather than windy conditions will be responsible for, will provide or will be making climate more conducive for temperature inversion.
But insulation and terrestrial radiation
Will not be there. Vertical radiation will not. The transfer of energy will be there in the case of windy condition, but it will be horizontal.
you can example during summer season there is
Now, when we are talking about seasonal, the situation will be different. When we are talking about regional aspect, regional pattern, the area one is having calm condition, other is having windy condition. So, area which is affected consistently by trade wind will not be producing temperature inversion condition, right? And all these, if you see, that's the general aspect. If you look at these areas which are more vulnerable for temperature inversion on the surface, areas which are more vulnerable for temperature inversion. Which one do you think the most important on the surface of the earth, and why?
Mountains.
Why?
so you give the reason mountainous area where it will
Valley
receive
index is
different sunlight
Hmm.
and top of mountain will receive more energy.
So during daytime, you will have mountainous region. But more important than that, you all have read it. Deserts will be one area, definitely. But even more important than that, we have. Deserts are definitely a very important area of temperature inversion.
Sea or ocean landform.
Coastal areas. Coastal areas will be least vulnerable for that because of mixing. Land breeze, sea breeze. Sorry? Which experience is longer? Why can't you talk about polar region? Albedo is highest. So where will that energy go? The only area which has permanent, roughly permanent temperature inversion condition is polar areas. Roughly permanent, even during summer season. Even when it is receiving sunlight, the rate of albedo is very high, in fact the highest. Albedo means the amount of reflected amount of energy, and because of high albedo, this area is the most vulnerable for, the reason being the high albedo. The second is desert areas. What about desert areas? Obviously, Because of high and steep temperature gradient. The reason is different here. Right? Third is urban areas are more vulnerable for temperature inversion as compared to the rural areas. Again, for that we can easily understand why is it so. Infrastructural setup, concretization, and most of the surface are metalled. Big buildings, concrete buildings, no space left for normal soily condition. So what will happen? That it will be heated very fast, right? And because of that, the evening temperature gradient will be much steeper. Consequently, the chances of temperature inversion will be much high. But urban areas are generally vulnerable more in winter season. Urban areas, because of this factor, is also called heat island. Because of higher temperature in the urban areas, it is called heat island.
Sir, if we compare northern hemisphere with southern hemisphere, then the temperature inversions of northern hemisphere will be more than southern.
Beautiful, definitely. Because southern hemisphere is homogeneous. Good. That's application of what you have understood. Beautiful. When we compare, the questions are asked, then you can apply it. Continental areas are far more vulnerable for temperature inversion than northern areas. Now, areas of convergence with contrasting air masses. Contrasting air masses means when the two air masses are coming and both have different temperature. So that area will be very vulnerable for temperature inversion, and that one area is subpolar low pressure. We'll discuss that later. Subpolar low pressure areas. These areas are highly vulnerable for temperature inversion. Right? Next areas is mountainous areas with conspicuous valleys. Right? Especially where the valley is very prominent. They have greater chances of temperature inversion for the reasons we have already discussed that. The top of the mountain, and that is a rare daytime phenomena. A rare daytime phenomena. Otherwise, mostly the temperature inversion will be taking place during nights. So here only you have a much greater scope of temperature inversion during daytime. The consequence of temperature inversion. The first, bringing stability in the atmosphere. When we say stability in atmosphere, that means lack of air circulation. this produces dry condition. This increases pollution. Now, wow, right?
But sir, vertical circulation will be there. Vertical circulation will be there.
In fact, vertical circulation will be absent. If there is any possibility, there may be a bit of horizontal circulation. But the area which is having that will be lack of circulation. Now, how? Just imagine, let's say that what is the normal condition? The surface is having higher temperature, whereas the atmosphere is having lower temperature. Now compare the air particle here. When the surface is having higher temperature, that means warm air, cool air, right? Normal circumstances. Warm air means lighter, cool air means heavier. So a lighter particle is below heavier particle. Instability. Hope you understand. So there will be upheavals. So what will happen? The heavier air particle will sink and will force the lighter particle to go up. So there will be vertical circulation. That is the normal condition. Whenever the normal distribution of temperature with environmental lapse rate takes place, will always have temperature inversion, chances negated. Right? What is happening in the temperature inversion? In the case of temperature inversion, the surface is having lower temperature, upper air somewhere is having higher temperature. So warm air and cooler air. So obviously warm air is located or situated above the colder air, which is heavy. Perfect stability. No need to have any kind of reshuffle. No need to have circulation. So that is how it brings stability. And an stable atmosphere doesn't bring rainfall, doesn't form cloud. And atmospheric circulation, if the atmospheric circulation is absent, then the mixing of air will not take place. So all the pollutions are basic pollutants are released by the humans close to the ground, right? Now imagine that there is a stability. So that pollutants which are released close to the ground are not being mixed up vertically. So they are confined in a relatively smaller area. If it is a spread, it will be distributed. So particle per millions, that's when we measure pollutants, that will be more in the case of absence of mixing, right? So that's how it takes place. That's why if the question is asked that urban areas or the pollutants in urban areas are higher in the case of winter season than in the case of summer season. That statement is true.
Yes.
Winter season, because winter season is more vulnerable for temperature inversion, and temperature inversion makes pollution, it increases the pollution level, right? Why? Because of temperature inversion. If it is asked in assertion, reason or statement and all, that is basically because of bringing stability in the atmosphere.
Sir, if we relate to pressure during temperature inversion, high pressure is there count.
Colder air.
High pressure.
It's not high pressure. It may not necessarily produce high pressure because the entire region may have the colder temperature. The region, some area might be having, and the difference might not be huge. So that does not necessarily produce high pressure.
So, but the movement of particles due to pressure on like high to low pressure.
That's why I'm talking about the very local phenomena. It is a temporary phenomena, right? For example, for few hours, if the atmospheric stability is there and the atmosphere is perfectly in a stable condition and there is no circulation, that means for that hour at least the transformation is not there. So by that ratio, the pollutants will be more, right? Hope you understand. Second impact is formation of fog and smog. Fog is defined as the clouds with its base on the ground, right? You all know that. Smog is fog plus pollution. Right? Mist, another variety of fog where the visibility is much lower, right? Especially if the visibility is less than 1 kilometer, it is mist, right? Dhund and kohra. Kohra is mist, dhund is fog, right? So that's why fog plus pollution, it is called smog. Now, why it will be produced? Basically because the ground temperature is lower, right? Since the temperature is lower, we'll talk it later, relative humidity will be higher. Temperature and relative humidity is higher. So the chances of condensation is higher. We'll discuss that later, why it is so, the relationship between temperature, relative humidity and condensation, but that is how it happens. So condensed particle will form fog.
Certainly, temperature and are gradient. During temperature inversion, there is a negative gradient.
So on the ground, in a temperature inversion, the ground temperature is much lower than the normal. So lower temperature means higher relative humidity, means chances of condensation is higher. So that condensed particle are nothing but seen in the form of dew. They are very minute particle, remains in suspension in the atmosphere because of the buoyancy of the atmosphere, right? So that's what the fog and smog will be there, and because of this will be problems in transport and communication, right? Because of this there will be accidents. Possibility of accidents are always higher during winter season. Because of this, there will be delay in commutation. Yes, beautiful. Labor productivity. The moment you have delay in commutation, it will affect labor productivity, which will definitely affect the overall income, saving and investment of the society, right? Mist and fog is the similar thing. The only difference is that when the visibility is more than 1 kilometer, that is called fog. When it is less than 1 kilometer, it is called mist. Then it's good for temperate crop. Rice is not a temperate crop. Rice is perfectly a tropical crop. And what happens in this case, especially let's say apple orchards. Now, what is the fundamental requirement of the temperate crops, or for that matter temperate forest, or any kind of vegetation which is exclusive to temperate region? That requires certain amount of frost in a particular period of time, right? So if suppose, especially in a tropical country like us, where all the areas may not be very suitable for frost generation, so some of the areas which are on the lower latitude, towards the lower latitude, let's say plain of Kashmir. So if you go to Himachal Pradesh, only in Himachal Pradesh, only the higher elevated areas are suitable for apple cultivation, right? Why? Because Himachal Pradesh is slightly closer. The moment you come to Uttarakhand, even that is not suitable because it is much closer to equator, so the temperature on height is more, right? But what happens even in Jammu and Kashmir, you see the area is, some of the areas are not very suitable to generate frost. But the moment if there is a chance of temperature inversion, that will bring down the temperature on the ground, and that will create foggy condition, and that will produce frost.
Why it is frost here? Cannot plain area.
It's specifically because of that. That's not frost, fog. Frost is something different. That will come back to that later. Like it is a question of basically when we understand precipitation and all. But just as a like in brief, it is when we talk about white frost, when the dew point temperature is negative, then the condensation directly takes place in the ice crystals on the close to the ground. That is frost. So that frost will be produced when the temperature is lesser than negative.
Is it पाला जो बोलते हैं पाला पड़ना
Ole.
पाला हो जाता है ना बिल्कुल जम जाती है बट पाला बोलते हैं
हाँ पाला बोलते, पाला तुम्हारे यहाँ नहीं होता होगा,
पड़ता है कभी
तो वो ओले हो गए, वो हेल स्टॉर्म हो गए.
ठंडियों में फसल को बोलते हैं कि पाला पड़ गया.
हाँ वो पाला दूसरी चीज. That's not frost. Frost is always associated with a region which has negative temperature, or at least dew point is in negative temperature. Dew point temperature is negative. Then you have crops in desert areas. It is suitable for crops in desert areas, right? When the temperature inversion chances in the desert area is higher, so obviously foggy condition will be there. There will be freezing. There will be water particles will condense. So that is helpful for crops. Like for example, in the Israel areas, the fog provides almost 35 cm of water in a year. It is a desert area, so that will definitely be very handy and helpful in different types of crops and agricultural activities. Distribution of temperature. Across the latitude. If you look at the lower latitudes, the temperature will be high. Higher latitude, the temperature will be low. This is what we call north-south energy imbalance. Why is it so? Basically because lower latitude on an average year-wise receives more insolation than it loses by terrestrial radiation. So it has surplus energy. That means this is what we call net radiation. Any place, the calculation between the incoming solar radiation and outgoing terrestrial radiation is called net radiation, right? So net radiation in this zone is positive, and net radiation in higher latitude is negative, right? For example, if you look at the diagram, roughly around 40 degree north to 40 degree south, the amount of insolation, in fact, if you look at this will be the case, and this is the terrestrial radiation. So this region will be deficit area, that is 40° north and 40° south. So overall net radiation balance, this will be area with surplus and this is deficit area in both the sides. That's what you call net radiation imbalance, created because of the difference in the net radiation. And these energy imbalance is fundamental to drive all the atmospheric phenomena, including atmospheric circulation, movement of air, generation of pressure gradient force, storms, weather phenomena, cloud formation, all are associated with this net imbalance in net imbalance in net radiation, north-south energy imbalance. Now, distribution, the older of the Greek distribution, which is still very popular, is the torrid zone. Torrid zone is generally taken between the tropics, that is 23.5° north to 23.5° south. This is treated as torrid zone. That means area has higher side of the temperature throughout the year. Why it is so? Because it receives, each place receives 2 vertical sun's rays, 2 times vertical sun's rays. Each place, because of the apparent movement of the sun northward and southward. That's what it's called, torrid zone with high heat zone. Now, in the modern days, it is further classified into equatorial zone. In the modern classification, the torrid zone is equatorial zone, generally between 5° north to 5° south. Then, tropical zone, generally between 5° to 25° north and south. That's further divided into this. This is having more practical reality with respect to temperature distribution, basically because equatorial region has different pattern of temperature. All of you might be knowing that equatorial region receives very high amount of rainfall, high humidity, high cloudiness. Consequently, the temperature pattern in equatorial region is different as compared to what we perceive because of the presence of vertical rays of the sun. नहीं समझ में आता है तो बात करते रहना है, ठीक है, खामोश मत रहना. मैंने बताया हुआ खामोशी हाँ की अलामत होती है. सुना है ये स्टेटमेंट, उर्दू का एक कोटेशन है, खामोशी हाँ की अलामत होती है. जनरली मुस्लिम में जब शादियां होती हैं तो लड़के से और लड़कियों से दोनों से पूछा जाता है कि क्या आपको ये निकाह वो लड़का कबूल है, ये लड़की कबूल है. तो आमतौर पे लड़के तो चल उछल के बोल देते हैं हाँ मुझे कबूल है, मुझे कबूल है. लेकिन लड़कियां खामोश रहती हैं, वो नहीं बोल पाती. बहुत सारे लोग रहते हैं जिस तरह से हमने पाल रखा होता है आमतौर पे, दैट इज इंडियन कल्चर, दैट हैज नथिंग टू डू विद मुस्लिम्स. तो वो खामोश रहती हैं। तो फिर मुल्ला बोलते हैं कि चलो भाई खामोशी हाँ की अलामत है, मुबारक हो निकाह हो गया। तो हाँ, इट डजंट मैटर जनरली। तो उसमें उसको तो खामोश आप लोग रहेंगे तो मैं समझूंगा कि आपकी हामी है उसमें। So if you keep on speaking, hopefully I'll be able to, you will find me much more productive and you will be learning more also. The second is, again the Greek classification is the temperate zone. Temperate zone, modern classification is equatorial tropical. इसमें से the torrid zone is further divided into equatorial and tropical. Now the older classification is basically frigid, torrid, temperate and frigid. 3 zones. That is purely based on the sun's rays. The temperate zone is generally taken from the tropics till 66.5 degree north and south. Earlier classification, Greek classification, right? Why this classification was there? Basically because the sun rays is available. Sun rays available throughout the year. No vertical rays. You have one maxima and one minima. Simple distribution of temperature. One maxima, one minima. That means extremes of summer and winter. When we say one maxima and one minima, like when the sun's rays, vertical sun's rays is close to the northern hemisphere, let's say Tropic of Cancer. So entire temperate zone of northern hemisphere will be closest to the vertical rays of sun. Extreme maximum temperature it can ever have within a year will be that situation. At the same situation, when the sun's vertical rays is at Tropic of Cancer, the southern hemisphere temperate region would be experiencing minimum, right? So one maximum, one minimum. When it goes here, the southern hemisphere will be receiving maximum and northern hemisphere will be receiving minimum. Unlike in the torrid zone where you have 2 maxima and 2 minima. Torrid zone where you can add one thing, 2 maxima and 2 minima. 2 maxima when the vertical rays of the sun is exactly overhead, and that will be twice a year. Minima when it is farthest from that particular place, particular latitude, that will be minima. Getting? समझ में आ रहा है कुछ? Then temperate region is further divided in the modern classification as subtropical region, between 25 to 35 degree latitude, right? Then we have real temperate region, generally between 35 to 55 degree latitude in both the hemisphere, and subpolar region between 55 to 65 degree in both the hemisphere. We'll discuss that later. The climatic condition in this area will be different. For example, the subtropical region is a region of high pressure area, and because of high pressure that area do not receive rainfall. So the dry condition make the temperature much higher during summer and much lower during winter. The temperate region is the real temperate region of the Greeks is similar roughly. in this belt.
That's the Sahara is
Subtropical, right? And subpolar low pressure area, that region is an area of low pressure. So the rainfall is on the higher side in this region. Consequently, the temperature is much lower than expected. Very often you will have frozen rainfall. So that's how these three regions are different from the Greeks' classification of simple temperate region. Then the third region as per Greek classification is frigid. That means, obviously the term itself suggests that frozen. That means the area with very low temperature. Right? That is 66.5 degree to pole in both north-south hemisphere. That is true even for present day. Now, what happens? This area does not receive sunshine throughout the year. So, the area has 6 months day-night phenomena. Because of angle of inclination or axial inclination. Axial inclination of Earth. Earth axis is inclined by 23.5, hence one pole remains away from the sun every time. Sometimes for the half of the circle, 6 months it is North Pole, the next half of the circle it is South Pole, and so on. They keep on repeating the same. Fine. So what is happening here? The daily insolation is highest. But temperature is generally lowest. Because of perhaps the highest albedo on the Earth. Why? Because of snow and ice covered areas.
the insulation also for 6 months or it's like 12 months?
6 months. 6 months continuous. Like we can see it here. For example, right now let's take this Earth in this position and imagine your head as sun, right? So obviously you can't see North Pole, right? When you can't see a certain portion of North Pole will not be visible. Even if it is rotating, South Pole will not be moving away from you, and North Pole will not be coming towards you. And this way it will keep on moving, and in the half circle till it is moving, it will be away. North Pole will be away and South Pole will be under the light. In the next half, the other side of the back side of your circle, northern like situation will be this. So North Pole will be coming under the light and South Pole will be away from the light. That's what you call circle of illumination, right? The circle of illumination will be here, will be passing here. Illumination, the circle or the line or the circumference which divide the lighter part with the darker part. So the circle of illumination will always leave one pole in half of the revolution, and in the another half, another pole will be left out.